We're told Xanax has a half-life of 11 hours in the bloodstream, and we're asked to set up a model where A is the amount of Xanax in the bloodstream T hours after ingesting A0 milligrams of Xanax. So we know that when T is 11, the amount A will be A0 over 2, because that's what half-life means. After that amount of time, the amount will be half of the original amount. So we use that fact, set up this equation, divide both sides by A0, get 1/2 time equals 1 minus r to the 11th. We can get rid of the exponent by taking the 11th root or raising both sides to the 1 over 11 power. And then I'll add r to both sides and subtract the 1 over 2 to the 1 over 11. Putting that number into any calculator, or that expression into a calculator, gives me 0.0611. That's about 6.11%, the rate at which Xanax is leaving the body per hour. So now I can write down my model. I'll write it in two different ways. I'll show you how to write it just by hand, and then also, oh, never mind. I'll just write it one way, using the decimals. 1 minus 0.0611 gives us 0.9389. And in part B, we're modeling the same situation with A0 times e to the negative kt, which is exponential decay instead of exponential growth, because we're saying that that exponent is going to be negative. And that makes sense in this case. You got some amount of drug in the bloodstream, and as time goes by, that amount decreases exponentially. So again, what we know is that after 11 hours, the amount is half of the original amount. So A equals A0 over 2. We could set up the problem like that and work it all out. Or we could just use the fact that we know K is natural log of 1 plus R, or in this case 1 minus R. We could have set this problem up as, in part A, it could have been 1 plus R instead of 1 minus R. Then we would have gotten a negative rate instead of getting positive 0.0611. We would have negative 0.0611. So when we take the natural log to get K, you just do the natural log of that 0.9389. And if you put that into a calculator, you'll get negative 0.063. And once we get the decimal approximation of K, we can just plug that back into the original formula, the original equation, and get A equals A0 times e to the negative 0.063